Hey guys, this is a quick waves and optics overview for Physics 1. So there's two types of basic waves, transverse waves and longitudinal waves. So for transverse waves, imagine you take a string and you shake it up and down. You would get something like this, and it would be moving from side to side. And a transverse wave is basically a wave that moves from side to side like this. The other type of wave is a longitudinal wave, where the wave's motion is forward instead of side to side. So imagine you had a bunch of air particles that are spread out like this, and then you applied a force to the left of it, and you would by doing this you would cause the air particles to bump into each other, and that would travel through the air. So you would end up with something like this. You would end up with a wave that's traveling forward instead of from side to side, and that would be a longitudinal wave. So here are the different parts of a wave. This would be the amplitude, and that would be the max vertical displacement of the wave. And these would be the nodes, which are the parts of the wave that don't move. And these would be the antinodes, which are the parts of the wave that move. And that would be the period of the wave. So wave characteristics. These are the equations that can be used to find the different parts of a wave. The first one is frequency equals 1 over period, and the frequency is the number of waves that passes a given point every second, and that would be the period, which is the time it takes to complete a cycle, and the wavelength would be the difference between the two heights, and that is equal to velocity over frequency, and the velocity is x over time. So here's a quick example problem. Extreme waves along ocean waters, sometimes referred to as rogue waves, are a focus of much research and study among scientists. Several merchant ships reports rogue waves, which are estimated to be 25 meters high and 26 meters long. Assuming that these waves travel at speeds of 6.5 meters per second, determine the frequency and period. The frequency is velocity over wavelength. We know the velocity is 6.5 meters per second, and we know the wavelength, which is 26 meters. So we can just plug that into the equation. So we get 6.5 meters per second over 26 meters. And that gets us 0.25 hertz. Okay, now we want to find the period of the wave. Well, the period is just 1 over frequency. And that would just be 1 over 0.25 hertz. And it would be 4 seconds. Electromagnetic waves consist of an electric field and a magnetic field positioned perpendicular to each other and perpendicular to the direction of propagation. Electromagnetic radiation is the transfer of energy by those waves, and the speed of that is the speed of light in a vacuum, which is 3.0 times 10 to the 8th meters per second, and that is equal to the frequency of the wave times the wavelength. There are three types of light: luminous, reflected, and filtered. Luminous light is when an object generates its own light. Reflected light is when an object is reflecting light from another source. And filter light is when a filter only allows a certain color to pass. So reflection is when light bounces off a surface. And the law of reflection is that theta I equals theta R, where theta I is the angle of incidence and theta R is the angle of reflection. So in this diagram, that would be theta I, which is the angle of incidence, because light is coming in from there, and that would be theta R, which is the angle of reflection, and those two should be equal, and this is for flat surfaces. The two types of reflection are regular and diffuse reflection. Regular reflection is when light reflects off a smooth, flat surface, and diffuse reflection is when light reflects off a rough surface. Refraction occurs when a wave enters a new medium. So when a wave enters a new medium, it will change velocity because it changes direction. So the speed doesn't change, but the direction changes. The index of refraction is the indication of the amount of refraction in a given material, and it's given by n. And the equation is C equals NV. The ratio for two mediums is C1 equals C2, or N1V1 equals N2V2. And here's a list of the index of refraction for different mediums. Snell's law describes the relationship between the angle of incidence and the angle of refraction. It is N1 sine theta 1 equals N2 sine theta 2, and you can arrange that in different ways. Theta 1 is the angle of incidence, theta 2 is the angle of refraction, and N is how fast light moves through that medium. The critical angle is the angle of incidence, where the angle of refraction is 90 degrees, and that equation is theta of the critical equals inverse sine of nr over ni. Here's an equation sheet for optics if you need it. So here's a quick example problem. A coin is placed at a depth of 15 centimeters in a beaker containing water. The refractive index of water is 4/3, and for small angles, tan theta equals sine theta. Calculate the apparent depth of the coin. So here we have Snell's law, N1 sine theta 1 equals N2 sine theta 2. And now we can rearrange that equation, and we get sine theta 1 over sine theta 2 is equal to N2 over N1. Now we know that N2 is 1 because the refractive index of air is 1. And N1 is equal to 4/3 because they give that to us. And the actual depth is 15 centimeters, and now we're looking for the apparent depth. So we can use that equation, and we replace sine theta with tan theta. So tan theta over tan theta 1 over tan theta 2 is equal to N2 over N1, which is equal to the apparent depth over the actual depth. So now we just solve for the apparent depth, and we get N2 over N1 times the actual depth. And that would just be equal to 1 over 4/3 times 15, and we would get 11.25 centimeters. So that's all for this video. Hope this helped.